Alright, so this is the discriminant video. So first off, what is the discriminant? In a quadratic equation, the discriminant will tell you how many real solutions you're going to get when you solve for x. So first, we're going to recall quadratic equations and how we go about solving those. So they're used in algebra to solve quadratic equations, which are polynomial equations to the second degree, such as x squared. So generally, quadratic equations will use x to represent an unknown variable, and a, b, and c are used as constants. Because these include a variable x to the second degree, it appears on a graph as a curve that crosses the x-axis in two spots. And these two spots, where x equals 0, are called the solutions or roots of the equation. So on a graph, that would look like this. Or it could be negative pointing downwards, but either way, it'll cross the axis twice, right here, which would be your roots or solutions. So we generally see this in a standard form equation, which would be ax squared plus bx plus c. So here's your unknown variable, and then a, b, and c are all constant values.
So now what we're going to do is we're going to discuss how you solve for roots. So if x cannot be solved by simply factoring or by completing the square, you have to use the quadratic formula. Which, if we go down here, so that is x equals opposite b plus or minus the square root of b squared minus 4ac, so that entire quantity, all divided by 2 times a. So all you do is you simply plug in the values of a, b, and c, and then you just do the calculations. So there are 2 answers, and these answers can either be real numbers or they can be imaginary numbers. So let's take a look. We're going to do an example here. So say we have the quadratic 5x squared plus 6x plus 1 equals 0. So what are our variables here? We have a is 5, b is 6, and c is 1. So we're going to plug that into our quadratic formula. So we have x equals negative 6 plus or minus the square root of 6 squared minus 4 times 5 times 1 divided by 2 times 5. So we simplify this. X equals negative 6 plus or minus square root of 36 minus 20 divided by 10. And that simplifies further to x equals negative 6 plus or minus the square root of 16 divided by 10. Square root of 16 is 4. So x equals negative 6 plus or minus 4 divided by 10. And so now, since it's plus or minus, this is where the 2 solutions come in. So what we have is we either have x equals negative 6 plus 4 divided by 10, which would simplify down to negative 0.2. Or, this is really important, there's a second solution here. It can be x equals negative 6 minus 4 divided by 10. And that gives you the solution of negative 1.
Alright, so how is the discriminant applied here? So, like I said before, in the quadratic equation, the discriminant is helpful in telling us how many answers we get will be real and how many will be imaginary. So this is simply found by using the section of the equation of the quadratic formula that's under the radical, which would be b squared minus 4ac. So that's how we find it, and it's represented here by this triangle. So some helpful hints. When this is positive, so write positive, you will get 2 real solutions. When this is 0, you get 1 real solution. So that basically means that you just get 1 answer, and it counts as 1 real solution because it's the same. And when it's negative, you will get two complex solutions. So that means at least one of them is an imaginary number or not real.
Okay, so now what we're going to do is we're going to quickly go back to the same example from earlier where we solved the quadratic formula. And now we're going to find the discriminant of this quadratic, right? So, how you do that is we know our formula is the discriminant equals b squared minus 4 times a times c. So for this one, it's the discriminant equals 6 squared minus 4 times 5 times 1. So that equals 36 minus 20. So our discriminant here is 16. 16 is positive. So if we remember what Katy just said, that means that it will have two roots that are both two real roots. Which this will make sense because when we went back and we did our other problem, our answers were negative 0.2 and negative 1. These are both two real roots.
And so an example of a complex would be a little bit different. Okay, so we'll do a different example with a different equation. Just one number is changed. It'll be 5x squared plus 2x and plus 1 equals 0. So you have your constants and you have a, 2, and 1. So discriminant equals b squared plus minus 4ac equals 2 squared minus 4 times 5 times 1 equals 4 minus 20. Your discriminant is negative 16. So this is a negative number, and if you check this in the quadratic formula, you'll get x answers that equal negative 0.2, but you also get plus or minus 0.4i. 4i is an imaginary number because I stands for an imaginary number, which is a negative radical, which is impossible to solve for. So this means basically just that the curve isn't crossing the x-axis there at that point.